Hello and welcome to the section on rational exponents and simplifying things with that. Starting this new chapter, we've just gotten off of a lot of factoring and a lot of deep stuff with polynomials and huge big rational exponents. Now, rational expressions. Now we're going to do some exponents. So let's review the rules of exponents that we knew from way back that we reviewed from Algebra 1. So if you take something like x squared times x to the fifth, the rule here is that when you multiply, that was the multiplication rule, they add x to the seventh power. That's because there are two x's here, five x's here, all times together you get seven x's. So then there was the x squared to the fifth power, and what did that end up doing? Well, that was x to the 10th power. And this was the power to the power rule. And a lot of power going on there. And then we had, what about x to the fifth over x squared? And this was the subtraction rule, because you had five x's on the top, two x's on the bottom. Two of the x's canceled. If you wrote it all out in expanded form, it was factored so they could cancel, which is kind of the same thing as when you had x squared over x to the fifth. If you do that in slow motion, you get x to the third on the bottom. And this is where we came up with the other rule. If you did 2 minus 5 on the top, then x to the negative 3 is 1 over x cubed. So there are two different ways to get here. One of them is seeing that the bottom one will win in subtraction with this rule, and the other one is, hey, that's what a negative exponent must mean. 2 minus 5 is a negative 3, so it must mean a reciprocal. And yes, that's what a negative exponent is. So this was the division rule, and this was the negative exponent rule, which means it flips, which when you flip a fraction, it flips back up to the top. So that would be 1 over x to, say, the negative cubed power, negative 3 power. It would flip back up to the top and become an x cubed. So 1 over a fraction, because when you divide fractions, you flip them, will come back up to the top. And then the last one was the zero rule. X to the 0 equals 1 for anything. All right, so the first thing we're going to do with rational exponents is find out what they are. So when we have something that says, I don't know, x to the 1/2 power, what in the world does that mean? And the secret lies in looking in the power rule right here. We know that if you take x to the 1/2 and you square it, these two exponents would have to, by this rule, multiply. That means you get x to the 1. That's an x. So squaring x to the 1/2 power will get rid of this 1/2 exponent. What else does squaring get rid of? Oh, look at this guy. That's right. For all positive numbers x, when you square it and you then square root it and then you square that, they undo each other. Well, will that work with the other things? Yeah, so x to the 1/3 and you cube it. Well, that's going to be x to the 1/3 times 3 is 1, which is x. And that's the same thing that happens over here. If you cube root a number and then cube it, they undo each other. They're inverses. And we see that a fractional exponent or rational exponent has to follow all these same rules. Certainly. But now we know what it means, that if you have a number on the bottom, that is a root. So this would be like a square root, and that would be a cube root. And it can keep going. X to the 1/4 power to the 4th power, that would be x to the 1 because of this power rule. They multiply. So yes, when you're dividing a fraction, it's going backwards of multiplying. And yeah, so there you go. Multiply. When you divide and you have a fractional exponent, that is a root. So that's x, and we could write it like this. The 4th root of x to the 4th. Yeah, they undo each other. And so that's what happens here with the multiplication of exponents. So there we go. Other than that, all these rules are exactly the same. So what does that mean for simplification? Well, instead of a problem like x squared times x to the 5th, you're going to get something like x to the 2/3 times x to the 5/8. And the reason this is so valuable, now you could write this as, oh, that's x squared with a cube root on it. These are the exact same thing. This is called radical notation. That's called rational, times the 8th root of x to the 5th. When you see these, you should think, I have no idea how to combine those. When you see these written in a fraction form and you know these rules, the natural thought is, wait a second, I know how to add fractions. That's right. Off on your scratch piece of paper, you're like, oh, 2/3 plus 5/8, common denominator, times by 8, times by 8, we get 16/24, times by 3, that's 15/24. That's going to equal x to the 31/24 power. And that is correct, allowing us to write roots as fractions in exponents allows all of the arithmetic that we know about fractions, add, subtract, multiply, divide, and allow us to combine x's with very, very different exponents. Kind of cool. So if you have something like y to the 7/8 over y to the negative 3/5, something like that, well, this guy would go up to the top, or you could use a rule and say it's okay, it's y to the 7/8 minus 3/5. That may take a little bit of work. 7/8 minus 3/5 times by 5 and 5, that's 35/40. Minus times by 8 and 8, and you get 24/40. This is going to equal y to the 11/40 power. What does that mean? 11th power, 40th root. Fascinating. So everything you've ever learned about moving these up and adding when you are multiplying and subtracting when you're dividing, and even this guy, y to the 7/8 power times z to the 3/4 power over c to the negative 5/9 power, all raised to the 0 power. That's right. It equals 1. So that is the first part of rational exponents that you will do. To the boards! Here's some for you to practice on. Go ahead and write these down, pause the video, and then resume when you're ready to see the answers. Put these in your video notebook. And welcome back. So here we have x to the 3/8 times x to the 3/4, and they will just add. So we've got to take 3/8 plus 3/4. Common denominator means we'd have to times each of these by 2. 3/8 plus 6/8, which would be 9/8. So this is x to the 9/8 power. Excellent. Number 2. Let's take this squared in and make sure everything gets squared. So we get 2 squared, which is 4. X to the power, that's 2/3. Y to the 5/8 squared is y to the 10/8. 5/8 times 2. Let's make sure we do that. That's 10/8. That's 5/4. Yeah, all the arithmetic of fractions we get to use now. So this is to the 5/4 power over 3 squared, which is 9. X to the 8/5 power. And y to the, what's negative 1/2 times 2? Negative 1. Okay, so there we go. This guy's going to go up to the top. And so we have 4 over 9. With the x's, we're going to take x to the 2/3 minus 8/5. So 2/3 minus 8/5 is, common denominator, 15ths. So we had times by 5, times by 5, 10/15 minus times by 3, times by 3, 24/15. So this is x to the negative 10 minus 24, so negative 14 15ths. Okay, and then the y has a 5/4 and a y to the 1. All right, so this guy ends up on the bottom. Oh, 8/5 was bigger than 2/3, so we could have subtracted the other way around and ended up with, let's write this out, 4 over 9. That's x to the 14/15. And this one is y to the 5/4 and y to the 1. So 5/4 plus 1 is 4/4, so that's 9/4. So y to the 9/4. There you go. Excellent. Okay, number 3. What does this one do? 2 to the 8 to the 5/8 and to the 0 power. They were trying to be tricky. Anything to the 0 power is 1. No trick there. All right, this is all straight multiplication. So we're going to have 3 times 5 times 2 is 30. And then x to the, we have 1. and 2/3 and 5/4. So 1 plus 2/3 plus 5/4. Let's add these two together first. 5/4 and 2/3, well, need to get a common denominator of 12. This is 8/12, times by 4 and 4, times by 3 and 3, and we get 15/12. And then this would be 12/12. Alrighty, common denominators there. So 12 plus 20, 12 plus 8 is 20, plus 15 is 35/12. So it's x to the 35/12. Whew, that's good. Okay, let's look at the second part of it. For future reference, let's make sure and write down a final rule, and this is the definition of a fractional exponent. We'll just leave it with a 1 over n. This is the same as the nth root of x. So I'm going to put it over here. This is the root rule, that the root can be written as a fractional exponent. Very important here. And why is it so valuable? Well, we're going to use it a lot later on, and particularly you need to become familiar with how it works with numbers. So, for example, if we know that 5 squared is 25, then that also means that 25 square rooted, or to the 1/2 power, equals 5. And if we know that 2 to the 3rd power is 8, then that means that 8 to the 1/3 power is 2. So see how they go back and forth like that? This is the cube root of 8 is 2. Ooh, we better do some more of those. What if we did 5 to the 4th power? That is 5 times 5 times 5 times 5 is 625. And that is, well, if you take 625 to the 1/4 power, you equal 5. 4th root of 625. Try some other numbers. 3 to the 5th power. Who knows what that is? Well, it's 243. Knowing this will allow you to do 243 to the 1/5 power, gives you the number 3. We can do by 5 times 5, 2 times 2 times 2, 5 times 5 times 5 times 5, 3 times 3 times 3 times 3. And we can do them from the beginning to the end, kind of like arithmetic. These are much tougher, the ones that come out nicely, to be able to do on your own if you don't know these. For example, if I were to write 343 to the 1/3 power, this is almost impossible to do if you don't know that 7 to the 3rd power is 343. If you do know this, this is a piece of cake. That's 7. Excellent. So you need to be aware that just like squares are really common, and we used them in factoring, and even cubes we used in factoring, let's write down all the squares. We have 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way down to 13 squared, 14 squared, and down there. These are the perfect squares. 100 to the 1/2 power is 10. 121 to the 1/2 power is 11. 144 to the 1/2 power is 12, and so on. Well, it becomes important, just like when you learn the multiplication tables, to memorize them. We need to know the powers. When we did sum and difference of cubes, we kind of had to know the cubes. So let's write those up as well, so you have them here. So 1 cubed is 1. 2 cubed is 8. That's 2 times 2 times 2. 3 cubed is 3 times 3 times 3, so that's 27. 4 cubed would be 16 times 4 is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. And 9 cubed is 729. And then 10 cubed, 10 times 10 times 10, that's 1,000. We saw those earlier, but it's very good to recognize these numbers. And similarly, there are some 4th powers that you're going to need to know. 1 to the 4th is 1. 2 to the 4th is 16. Now you should note that 16 is 2 squared squared. So 3 squared is 9. Squared is 81. 4 to the 4th, 4 squared squared, is 256. So in knowing perfect squares, you ought to get at least, well, there's 15 squared. 16 squared is right there. Okay, and let me see, 1, 2, 3, 4, 5 squared to the 4th power is 625. We did that one right there. So we really ought to go all the way up to 25 5 squared to be able to know that one really well. Let's write down, this is 16 squared, 17 squared is there, 18 squared, that's 18 squared is 324, 19 squared is 361, and 20 squared is 400. And then skip down to 25 squared, 625. These are really the squares you need to know. And if you know these, then you know those fourth powers as well. And that's as high as you need to go. When you go to fifth powers, then we have 1 to the fifth is 1. 2 to the fifth is this times 2. 3 to the fifth is that one. And 4 to the fifth is over 1,000. So we don't really go that high. To the sixth power, we actually go even less. Just that one, and then 2 to the sixth is 64. And then 2 to the seventh, I'll write this one down, is 128. And 2 to the eighth is 256. There you go. So these are all of the powers that we're going to be working with. But we need to know that, yeah, you got to get some practice with these. So if you see something like 512 to the 1/3 power, and you have it right here, 512 to the 1/3 power, that's 8 cubed, so to the 1/3 power is 8. But this allows you to do more stuff. Let's do something like 81 to the negative 3/4 power. We've got to take the fourth root, remember what that is, fourth root, so right here is 81. Fourth root would be 3. Then we have to take it to this power, cubed, is 27. And what does a negative exponent do? It puts it on the bottom. This is 1 over 27. We better do another one just to make sure you got that, because you're going to be able to fill out an exponent monster. So let's try this one. 243 to the negative 3/5 power. So you're going to take the fifth root of 243, cube it, and then put it on the bottom. So fifth root of 243 is 3. Cubed is 27. So this is also 1 over 27. All right, let's send you to the boards and have you practice a few. To the boards! All right, here's some problems for you to work out. We've given you a little bit of a cheat sheet down here to help you out with those. If you haven't memorized them yet, go ahead and give them a shot and press play when you are ready to resume. All right, let's see how you did. 8 to the 5/3 power. You got to find the cube root of 8. So where is that? The cube root of 8 is 2 to the 5th power. So 2 to the 5th power is over there, 32. So cube root, 5th power. There we go. And it kind of looks like this. We are taking 2 cubed is 8, and 2 to the 5th power is, let's write it like that, 2 cubed. So we went cube root down to 2, and then that takes it 5th powered it up to 32. All right, 16 to the negative 1/4. So we've got to do the fourth root of 16. So that is 2. To the first power is 2, but it's a negative exponent, so it's 1/2. Good. 32 to the 7/5 power. 32, fifth root, we're doing a lot of 2's here, is 2 to the 7th power is 128. All right, 729 to the negative 2/3 power. So we're going to take 729, which is right here, cube root it, so we get 9. Squared is 81. But this is a negative exponent, so that puts it on the bottom. 125 to the 2/3 power. So we've got a cube root 125. So that'll take us there to 5 squared is 25, and it is not on the bottom. There you go. Good luck filling out your own exponent